maximum ampacity, or current carrying capacity of 12-2 wire is 20 amps. Whether fire risk or an open conductor occurs first depends on several factors, including wire insulation quality, ambient temperature, and the duration of the overload. Fire risk is higher if the wire insulation is damaged or old. Overheating for prolonged periods can cause the insulation to melt and ignite, resulting in a fire. An open conductor occurs when the current flow is interrupted due to excessive heating and melting of the copper wires. This is less likely to occur before a fire, as it requires a higher temperature. At 19.7 amps, the wire getting warm indicates that it is overloaded. However, it may not immediately catch fire or open a conductor. Continuous operation at this level may lead to insulation damage and increase the risk of fire over time. To avoid any potential hazards, it is recommended to not operate the Tux at 19.7 amps. Consider using multiple circuits or larger gauge wire, for example, 10-2 or 8-2 if necessary. Monitor the wires regularly for any signs of overheating or insulation damage. Contact an electrician promptly if any issues are observed. It is important to understand the factors that contribute to wire overheating and potential hazards. Firstly, wire insulation plays a critical role. Insulation is designed to protect the conductor and prevent electrical current from unintentionally flowing to other objects, which can cause a short circuit and potentially a fire. If the insulation is damaged, cracked, or deteriorated due to age or environmental factors, its ability to contain the electrical current is compromised. This can lead to current leakage and arcing, both of which generate heat and increase the risk of fire. Secondly, ambient temperature also affects wire ampacity. The stated ampacity ratings for wires are typically based on standard operating conditions, often around 30 degrees Celsius or 86 degrees Fahrenheit. However, if the surrounding environment is significantly hotter, the wire's ability to dissipate heat is reduced. This can cause the wire to operate at a higher temperature than intended, potentially leading to insulation breakdown and a fire hazard. Thirdly, the duration of overload is another important factor. A brief overload, where the current slightly exceeds the wire's ampacity rating for a short period, may not cause immediate damage. However, prolonged or repeated overloads can gradually degrade the wire's insulation and increase the risk of failure. The longer the wire is subjected to excessive current, the more heat it generates, and the greater the likelihood of insulation damage. Now let's delve into fire risk in more detail. Fire risk is significantly elevated when wire insulation is compromised. Damage can occur due to physical operation, chemical exposure, or simply the aging process. Old insulation becomes brittle and less effective at containing electrical current. Overheating for extended periods is the primary cause of insulation failure. When a wire operates above its rated ampacity, it generates excessive heat, which degrades the insulation over time. This degradation can lead to melting, cracking, and eventual failure of the insulation. Once the insulation fails, the exposed conductor can come into contact with flammable materials, resulting in a fire. Now let's discuss open conductors. An open conductor occurs when the electrical path is broken, typically due to the melting or severing of the copper wire itself. This usually happens as a result of extreme overheating caused by a severe overload or a short circuit. While it is less likely to occur before a fire, it is still a potential consequence of electrical overload. The temperature required to melt copper is considerably high. So, the insulation is more likely to ignite before the conductor melts entirely. However, if the overload is severe and sustained, the conductor can reach its melting point and break, interrupting the current flow. It is important to understand what happens at 19.7 amps when using 12-2 wire. At 19.7 amps, the wire is operating very close to its maximum ampacity. The warmth you feel indicates that the wire is generating heat due to the electrical resistance. While it may not immediately cause a fire or an open conductor, continuous operation at this level is not recommended. Over time, the excessive heat can degrade the insulation, making it more susceptible to failure. This can lead to a gradual increase in fire risk. It is important to take proactive steps to mitigate these risks. If you are consistently operating the tubes for relays near the wire's maximum ampacity, it is essential to consider alternatives. Firstly, using multiple circuits can help distribute the load. Instead of powering all the tubes for relays from a single circuit, you can divide them among 2 or more circuits. This reduces the current flowing through each individual wire, minimizing the risk of overheating. Secondly, upgrading to a larger gauge wire is another effective solution. Wires with larger gauges, such as 10-2 or 8-2, have higher ampacity ratings. This means they can safely carry more current without overheating. Replacing the 12-2 wire with a larger gauge wire provides a greater margin of safety. Thirdly, monitoring the wires regularly is crucial. Periodically check the wires for any signs of overheating or insulation damage. Look for discoloration, melting, cracking, or brittleness of the insulation. If you notice any of these issues, it is essential to take immediate action. Fourthly, if you observe any problems or are unsure about the safety of your electrical system, contact a qualified electrician promptly. A professional electrician can assess the situation, identify any potential hazards, and recommend appropriate solutions. They can also perform necessary repairs or upgrades to ensure the safety of your electrical system. Understanding the ampacity of electrical wires is crucial for safety. The National Electrical Code, or NEC, specifies the allowable ampacities for different wire gauges and insulation types. These ratings are based on extensive testing and are designed to prevent overheating and fire hazards. The NEC provides tables that list the ampacities for various wire types under different conditions. For example, NEC Table 310.16 lists the allowable ampacities for insulated conductors rated up to 600 volts. It is important to consult the NEC and follow its guidelines when installing or modifying electrical wiring. Using the wrong size wire for a particular application can lead to dangerous consequences. For example, using a 14-gauge wire, which has a lower ampacity rating, to power a circuit that requires 20 amps can cause the wire to overheat and potentially start a fire. Always ensure that you are using the correct wire gauge for the intended load. Circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. These devices are rated to trip or blow when the current exceeds a certain level. For example, a 20-amp circuit breaker is designed to trip when the current exceeds 20 amps. This prevents the wires from overheating and potentially causing a fire. It is important to use the correct size circuit breaker or fuse for the wire gauge. Using a circuit breaker or fuse with a higher rating than the wire's ampacity can defeat the purpose of the protection device. For example, using a 30-amp circuit breaker on a 12-gauge wire, which has an ampacity of 20 amps, can allow the wire to overheat without tripping the breaker. In addition to following the NEC guidelines and using the correct wire gauges and circuit breakers, it is also important to practice general electrical safety. Always turn off the power before working on electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Never overload electrical outlets or extension cords. Avoid running extension cords under rugs or carpets, as this can trap heat and create a fire hazard. If you are unsure about any aspect of electrical safety, consult a qualified electrician. Electricity can be dangerous if not handled properly. Taking the necessary precautions can help prevent accidents and ensure the safety of yourself and others. Regular electrical inspections are also important for maintaining a safe electrical system. A qualified electrician can inspect your wiring, outlets, and circuit breakers to identify any potential problems. They can also perform necessary repairs or upgrades to ensure that your electrical system is up to code and functioning properly. It is recommended to have your electrical system inspected at least every few years, or more frequently if you have an older home or have made any recent electrical modifications. By understanding the ampacity of electrical wires, following the NEC guidelines, and practicing general electrical safety, you can help prevent electrical fires and ensure the safety of your home or business. Remember, electricity is a powerful force that should be treated with respect. Taking the necessary precautions can help protect yourself, your family, and your property. If you have any questions or concerns about electrical safety, always consult a qualified electrician. They have the knowledge and expertise to provide you with the best advice and solutions for your specific situation.